Alright, a few more examples we're going to solve like we've been doing. Okay, so the first one, x squared minus 2x plus 2 equals 0. We could do as we have done earlier and complete the square. We could complete the square and solve this one. So you can actually use, when it's a quadratic like this, you can actually just use the quadratic formula. So if you've got a x squared plus bx plus c equals 0, the quadratic formula, x equals minus b plus or minus square root of b squared minus 4ac over 2a. That's the quadratic formula. So for question 1, solving this, we get a is 1, b is minus 2, c is 2. So x is going to be negative upper negative 2, which is a plus 2, plus or minus square root of b squared negative 2 squared minus 4 times 2 times 1. All of that over 2 times 1. So it equals 2 plus or minus square root of 4 minus 8, so that's minus 4. Okay, this is where the complex part comes in, because this gives us complex roots. So we get 2 plus or minus square root of minus 4 is 2i over 2. So x equals 1 plus or minus I. So that can be easier than using the complete the square. If you were to write it as factors, if you were to write this as factors, you'd have the two factors are 1 plus I, 1 minus I, so you'd have x minus 1 minus I times x minus 1 plus I. Those would be if you wanted to factorize that. Alright, number 2. X cubed plus 3x squared plus 8x minus 12 is 0. So we've got to guess one of our 3 roots. We've got 3 roots here. Guess one of them. And if you look here, it's quite easy for this one, because you've got if you look, 1 plus 3 plus 8 is 12, minus 12 is 0, which means that x equals 1 is a root. Alright, if you substitute 1 into this equation, the left side is going to equal the right side. So we already know that x minus 1 is a factor. Yes. So we can then do what we did earlier. Px squared, we know that this, we've got to times this by a second degree polynomial. And when we times that all out, we're going to get this right side. Okay, so just another one of these. So let's just go through step by step. Let's times this out. So we get px cubed. We get a, let's just do this all in one step. We're going to get a q, and we're going to minus a p times x squared. Okay, because x times qx gives me the qx squared. Minus 1 times that gives me the minus p. Alright, and then we're going to get positive q, the next one is just a plain x. So we've got a positive r times x, and we've got a minus q times x. And then we've got a minus r equals all that. P is 1, p's got to be 1. 1 and 1x cubed. Q minus p is 3, p is 1, so that makes q 4. And r is 12, because this has to equal this. And just double checking, r minus q is at 8, 12 minus 4 is 8. Alright, so that's done. So this factorizes to x minus 1 times x squared plus 4x plus 12 equals 0. Alright, so really, to solve this, we know that this gives us one of our factors 1. We could use a quadratic, or we could complete the square to solve this. We did quadratic formula last time, let's just do it again. Alright, so we're going to get minus 4 plus or minus square root of 4 squared minus 4 times 12 times 1 over 2. Minus 4 plus or minus 16 minus 48. That is a 16 minus 48, negative 32, I think, yep, 32. Let's see, which is minus 4 plus or minus, this is 16 times 2 times negative 1, right? 16, square root is 4, 2 is the square root, minus 1 gives you I. So we get, divided by 2 minus 2 plus or minus 2 square root 2i. Okay, so therefore x equals 1 minus 2 plus 2 square root 2i, or minus 2 square root 2i. Alright, last one. x4 plus 13x squared plus 36 equals 0. Okay, when we've got even powers, this is like a quadratic, but we could make a substitution y equals x squared and go from there, but we could also just do that in one step. Okay, I know that this is going to be, that's because 9 times 4 is 36, and 9 plus 4 is 13. Okay, so this one, now I've got x squared. This, we can write these difference of two squares, so minus square root of 9. X squared minus negative 4 is 0. So this is x squared minus the square root of negative 9 squared. X squared minus the square root of minus 4 squared equals 0. Which is, this is 3i and this is 2i. I don't know why my arrows are facing different ways there, but this becomes x plus 3i, x minus 3i, x plus 2i, x minus 2i equals 0. So x equals plus or minus 2i plus or minus 3i. And that is the solution. We're done.